Hi all, welcome back to software engineering course. Let's get started. Today we will see how to manage the evolving code. So evolving is nothing but gradually increasing, okay, or gradually developing. So we will look into how to manage this gradually evolving or gradually developing the code. There are two topics over here. It is source code control and build is one type, and the other one is refactoring. So first we will understand what is managing the evolving code. Okay. Now what happens during your coding process is that the code is being written by the programmers or pair of programmers, right? So what happens in the development process is like it starts from nothing to it gradually increases. Okay, it gradually increases, and so that at the end you will have a well tested module, right? So during this process, your code undergoes many changes. Besides your development process, the code changes are also needed due to your module specifications, or there might be requirement changes also, right? So in such dynamic scenarios, okay, so what happens is that it becomes a challenge to manage your incrementally developing or gradually developing of the code. So we will discuss the two aspects of that. So how to manage different versions that get created and how to maintain code quality under the changes. The first one is source code control and build. Let's look into this, like what will happen here. So in a project, we will have many different people developing the source code, right? So it is not the case like we have only one developer. We will be having many developers. So they they will code different functionalities. So they will be having multiple source codes, right? Each developer will be having his own source code. Now, whenever the programmer creates a source code files, so what they will become is like they will eventually evolve it. That means, so the programmer or the developer first he starts writing the code of say some functionality, then he will add something to it. So likewise he will improvise, or he will eventually he will evolve the code. He goes on adding the some content to the previous file. Now, your programmer he keeps on changing the source files as the code evolves, and then makes changes in other source file as well. So, in order to keep control over the sources, that means the source files and their evaluation, a source code control is required in the projects, right? So, we have tools like CVS on Unix and VSS on Windows. So, CVS means concurrent version systems and VSS means Visual Source Safe. Okay, so we will discuss about CVS, how it will work. So the code control system, it contains a repository. Your CVS, it would contain a repository. That means it will have a directory structure which will keep the revision history of the files produced by different developers or programmers in a team. So a file history, it is kept as deltas or increments from the base file. Suppose you have created a source file, okay? So whatever you create that source file, that will be in your local. That means that will be in your system. So you have to upload that file to the repository. So once you have uploaded that file to repository, say suppose there is some developer, he would be needing your code so that he can write his code on top of your code. So if you place your file in the repository, what he can do is like he can download the file and he can add his code to that your source code. Okay. Now for a project, a repository has to be set up with certain permissions. So all of them cannot go and simply create a repository. So that is a center place and it has to be done with certain permissions. So who can put files into that, who can take the files from that, these all things must be mentioned. So there are typical some commands would be there, so that would be used by the developers. So for example, you have a to get a local copy, that means you have say some file in the repository, you want to take it and save it into your repository, save it into your local system. So you have to use a command called as checkout. Okay, now, so once you do this checkout, once you execute this checkout command, checkout, what you have to do is you have to give the module name or the file name. So what happens is, like, whenever you execute that command, that particular file will be from repository, it will be copied to your local in the sense your local machine. Then what you can do, you can edit that particular file. So whatever you edit, it will be in your local. Now say suppose you want to, whatever you have done to that file, you have to move back, or you have to put it back to the repository. So then we will use a command called as commit then file. So what this will do is, like, whatever you have done, changes to the file in your system, that particular file would be put back to the repository or committed back to the repository. So once you put back the local file to the repository, so it will be available to others. Then we have another command called as, suppose say, to update a local copy. So we use a command called as update, right? So then we have another command called as this one, get reports. So it would take or generate the reports. Okay, so we have to note here, say once the changes are committed, that means once you put something into the repository, it will be available to all the members in the team. So that they can check in, they can check out or take back the file whatever you have put in the repository. So it is essential that a programmer commits a source file only when it's in the it's in a state that is usable to others. You cannot put something junk file into the repository or half written code into the repository. So whatever is given to you, you have to write it properly, you have to save it in your local, then put into the repository. Okay, so the programmer or the developers, they there is no need for them to maintain all the versions, or at any time if some changes are needed to be undone, or he has to remove some of the changes, so he can get the older versions very easily from the repository. So for this we use an activity called as build. Okay, so this build, it is used for constructing the software system from the sources. This build activity, it gets the latest version or the desired version number from the sources from the repository, and it will create executable from the sources. So building the final executable is done through the tools like makefile. Okay, so it will specify the dependence between the files and how the final executables are constructed. These tools are capable of recognizing that the files have changed and will recompile whenever these files are changed for creating the new executables. Getting it? So with this source code control, these tools will be generally get the latest copy from the repository. Okay. Now we will discuss the second thing, that is refactoring. Okay. So we have already know that, like, coding, it often involves making changes to the existing code. You write some code, you edit it, you put some extra code, you delete some of the code. So these changes happen throughout the coding activity. Again, your code also changes whenever there is a requirement change or whenever the clients give you a new functionality, right? So due to the changes being done to the modules, even if we started with a very good design with the time, we often end up with the with code whose design is not good as it could be. Maybe we had during design phase we have done it properly, but as the time goes on, suppose your requirement changes or the new functionality is added, so at the end we might not get a proper or a good design. Okay, so once your design, it has changed, your code becomes complex. That means enhancing of the code to have the new changes, that becomes difficult, it becomes complex, it becomes time consuming, and it might have many errors in that. So basically what we can tell is, like, the productivity and quality, it will start decreasing. Now we have a refactoring technique. So this technique, it is used to improve your existing code and prevent the design decay with time. That means it is a part of coding that is performed during the coding activity itself, but is not a regular coding. Okay, refactor is not your regular coding. Getting it? It is a part of coding. So it has been practiced in the past by the programmers, but in the recent times it has taken more concrete shape. Okay, so it also plays an important role in your test driven development or code improvement step in the TDD process. So, refactoring it is defined as a change it is made to the internal structure of the software to make it easier to understand and cheaper to modify without changing the or without changing your observable behavior. So we have to understand here is that change is being made to the design in the source code, that is the internal structure, for improvement purposes. The basic objective of the refactoring is to improve the design. So we have to note that here it is not about improving a design during the design stages, but in the later stages where whenever your coding is in progress. Okay, fine. So the refactoring it generally results in reduced of the coupling, increased cohesion, a better adherence to open closed principle. Your refactoring it involves changing the code to improve its one of the design properties while keeping the external behavior same. Your functionalities would remain same but the design might change. It is often triggered by some coding changes that have to be done. Say if you have to make some enhancement to the existing code, it is felt as if your code structure was different, then the change could have been done easier. So it is the time to do with the refactoring to improve the code structure. So even if the refactoring is triggered by the need of changing of the software, it should not be confused or it should not be mixed with the changes of the enhancements. It is best to keep these two things separated. Okay. So while developing of the code, if refactoring is needed, then you are programmer or as a programmer you should be writing of the new functionality or and first do the refactoring and then add the new code, right? So the main risk of refactoring is that existing code may break due to the changes you are making now. So the main reason why the refactoring is not done is like, so there is a high chance of breaking the existing code. So there are two golden rules for refactoring or to mitigate the risk, to overcome the risk of breaking the existing code. There are two rules. So one is like refactor in the small steps, and the second one is like have your test scripts available to test the existing functionality. So if you have a good test suite, then whether the refactoring preserves existing functionality can be checked easily. That means, so say suppose the first thing is refactor in small steps. You have to change the code such that or the design such that in small increments you have to do the changes. All at once do not do the changes. And the second one is like you have to make sure you have not broken the existing functionality. This can be easily tested if you have the test scripts. That means whatever previously the code was written for, that test script should be there. Have that, and once you have refactored the code, use the existing test script or run the test script such that you will come to know by making any changes to the code have you broken something or not. Okay. Now this process of executing the test suite or the scripts, it is easier if you have the automation in process. Manual would take time, manual testing. So it is always better to have the automated test suite. Then the refactoring usage can also ease the design task in the design stages. This means the designers they spend considerable effort in trying to make the design as good as possible. They try to think of future changes and try to make the design flexible enough to accommodate all types of future changes they can foresee. So this design activity is very complex and it results in complex designs. So if you have refactoring in place, the designer does not have to be worried about making the best or most flexible design, but the goal is here to come up with a good and a simple design. And later if new changes are required that were not thought of before, or any shortcomings are found in the design is changed through refactoring. So the extra flexibility and the design is never needed, resulting the system to be less complex. So we have to understand here that refactoring is not a technique for bug fixing or improvising your code that is in a bad shape. It is done to code that is mostly working. The basic purpose here is to make the code live longer by making the structure healthier, right? So now we have to understand that when this refactoring is needed. So there are some easy spot signs in the code which are sometimes called as bad smells. Okay, so these are the spots which are called as bad smells in the code. So they often indicate that refactoring might be needed. So they say that the design properties may be getting violated. So these, if you smell these bad smells, then it is a sign that refactoring is needed. So first of one of them, the bad smell is like duplicate code. So this is quite common, right? So one reason for that is that a small functionality is being executed at multiple places. For example, like your age from the date of birth may be computed in the each place wherever you have the date. So another common reason is that whenever there are multiple subclasses of a class, then each subclass may end up doing the same thing. Your duplicate code means that if this logic or function has to be changed, it will have to be changed at the all places wherever it exists. So whenever you have duplicate code in your source files, you have to remove that. The second one is long method. So if a method is large, your function is large. If it often, it represents that the situation where it is trying to do too many things and therefore it is not cohesive. So we have to remove these long methods. Next is long class. Like we have seen the long methods in the large, long class, it may indicate that it is encapsulating multiple concepts. So again, making the class not cohesive. Then the fourth one is long parameter list. So your complex interfaces are clearly not desirable. They make the code harder to understand. So we have to have, we should not pass many parameters. Long parameter list should be avoided. The next is switch statement. So if the object oriented in object oops concepts, if the polymorphism is not being used properly, it is likely to result in a switch statement where the behavior is to be different depending on the property. So presence of similar switch statements at different places is a sign that instead of using a class hierarchy, a switch statement has been used. Again, your switch statement it will make the developer's job harder. So that means code could be complex. Okay. So if a new category is to be added in that switch statement, all the switch statements have to be modified. Okay. So these are the basic things, these are the basic bad smells, what we call in the code. So if you could see all these things, you have to have the refactoring. Okay. So this is all about your managing and evolving code. Next, we will study about unit testing. So in unit testing, we will study about testing procedural units and unit testing of the classes. Okay. First, we'll study what is unit testing. So once the programmer he has written the code for a module, it has to be verified, right? So before someone uses his code, he has to verify it. That means he has to test it. Now this testing remains the most common method of this verification. At the programmer level, the testing is done only for checking whether the code the programmer has developed, you know, it's working fine or not. And this is called as unit testing. Unit testing, you have to understand that it will be done by the programmer or the developer himself. He will check whether the code he has written for a module is working fine or not, whether it has any errors are there or in that particular module or not. Okay, so it is your unit testing is like any regular testing where the programs are executed with some test cases, except that the focus is only on the smaller programs or the modules which are typically assigned to one programmer or a pair of programmers for coding. So in the programming processes, whatever we discussed earlier, the testing was essentially a unit testing. A unit may be a function or a small collection of functions for procedural languages, or a class or a small collection of classes for object oriented languages. So, testing of the modules or the software systems is a difficult and challenging task. Selection of the test case is a key issue for any type of testing. Okay, so during unit testing, the tester, who is again he is a programmer or the developer, he will execute the unit with a variety of test cases and study the actual behavior of the unit or module for these test cases. Based on the behavior, the tester he will decide whether that unit is working properly or not. So if it is not working properly, he has to fix it. That means if the behavior is not as expected for some of the test case, then he will find that there is some defect in the program. So he has to debug it. He has to debug in the sense he has to resolve the defect and he has to test it again. So after removal of the defect, the programmer he will again execute the test case which had failed previously to ensure that the fixing has actually worked or whatever the fix he has given is proper. Now we will discuss about testing procedural units. So in the last chapter we had seen, right, whenever there is a procedural units for modules, we can use the structure chart in which we have nodes as functions and edges it will act as a relationship. So in unit testing, one or small collection of these modules is to be tested with a set of test cases. So in this, the developer who will act as a tester, he will select different types of the test data to give it as an input to the function or whatever the source code he has written. So a issue with the unit testing is that it is not a complete system test, or it is a just small part of the testing or a small part of the whole system which is being getting tested, and it is not executable by itself. So, in its execution, it may use other modules that may not have been developed yet. So, due to this, your unit testing it requires often, it requires drivers or stubs to be written. Okay, there are two things which has to be, we have to consider while unit testing, that is driver or stubs. Your drivers they act as a role of calling a module and they are often responsible for getting the test data executing with this unit and then reporting the result. And then stubs are usually dummy modules that are used in place of the actual module to help in unit testing. Say for example, if a module M it uses the service from module N, that is another module. Okay, we have two modules here, module M and N. M uses services of N, and say suppose that N has not yet been developed, but you have to do a unit testing for module M. So you have to write some stub for N, which will have to be written so that your M can invoke the services in N, so that your unit testing can proceed. So you have to understand here that the need for stubs can be avoided if the coding and testing proceed in a bottom up manner. That is, the modules at the lower levels are coded first and tested first, such that when the modules at the higher levels in the hierarchy are tested, the code for the lower modules is already available. Okay. Next we will study about unit testing of the classes. So in the object oriented programs, that is OOPS, the unit what you have to test, right? It is basically the object of the class. Okay. So for testing the object, what you can do is like you have to run the routines provided by the object or run the methods that are provided by the object, and the goal here is to again uncover the errors in the implementation. So to test any class, say suppose the developer has written some code and it has a class, for testing of that particular class, he has to create the object of the class. Then you have to take that object to a particular state. Then after that you have to invoke the method on that particular object. After that you have to verify whether the state of the object is as expected. Now, this sequence has to be executed many times for the method, and it has to be performed on all the methods. So, for say for example, for Java, you have a framework called as JUnit. So this is for Java, and we have some other frameworks for the other languages like C++ and C hash. Okay. So whenever you want to test a particular class, the tester, that means the developer in unit testing, he has to create another class which will inherit from JUnit. Then after that, he has to create a object of that. Okay. So we can use a constructor or setup method for creating the objects and setting up the value. So once that is done, you have to run the methods on that particular object. So the methods would be named something like this one. Okay. So these method, it focus on the testing of a particular method which is under some state. So if the method, it has to first set up the state if it is not already set up by using a setup method, which is this one. Okay. And then it has to execute the method which has to be tested. For checking of the results, again the JUnit, it provides two other methods called as assert true and assert false. Right. So this is your unit testing of the classes. How to, what is the process while unit testing of a class, and we had also seen testing how to test a procedural unit. Now we'll have a quiz. The question is, Dash is the technique to improve existing code and prevent the design decay with time. You have got a minute of time to respond. Okay. Okay. Time up. That's it for today. We'll conclude our session. Thank you.